In some cases, you are given a description of a chemical equation, and you must be able to take that information and transform it into a balanced chemical equation. So here are the general steps that I like to give when you're first learning how to convert these descriptions into chemical equations. So the first thing I want you to do is always read the description more than once, just to be sure that you pick up on the information that is provided in the statement. Write the chemical reaction in words. So when we do practice, I'll show you what I mean by this. Then write an unbalanced chemical reaction. And when you write your unbalanced chemical reaction, we need to be sure that we're using the correct chemical formulas for the compounds. So this is where naming compounds and writing correct chemical formulas come into play. So if you're given the name, you need to know how to write the correct chemical formula, or else your balanced chemical equation will not be correct. So this is where you'll have to continue to review your naming rules so that you're always sure to be using the correct chemical formulas. Then, once you have your unbalanced chemical reaction, we'll add in physical states. In most descriptions, it will indicate to you what the physical state is of the substance: solid, liquid, gas, or aqueous. And then we will balance the chemical reaction. So looking at the next slide here, on this slide, we're going to see that there are 3 different descriptions. We're going to go through each one of these and write out the balanced chemical equation for each. So the first one reads, burning solid sodium in the presence of chlorine gas to produce solid sodium chloride. During this process, energy is released. Okay, so let's reread the description and get an understanding of identifying what are the reactants and what is the product. In this case, there's only one product. So looking here, it says solid sodium in the presence of chlorine gas. So those words there indicate that these are the 2 substances that are being combined together to react. So we have solid sodium reacting with chlorine gas. Then it says to produce solid sodium chloride. So anything that's produced is going to be on the right side of your product side. So let's switch over to the whiteboard here, and we are going to look at, hold on. Let's see. Okay. All right, so on the whiteboard here, I'm going to write out our chemical reaction in words first. So we know that we're reacting solid sodium plus chlorine gas to produce is going to be where we put our arrow, solid sodium chloride. Okay, I ran out of space there. Wrote a little too big or something, but that's okay. Okay, so the first thing we need to do is write the correct chemical formulas for an unbalanced chemical reaction. So solid sodium. When it's written as solid sodium, we know that it is in its metal form. It's not combined with any other elements, so it is not in its compound form. It's in its elemental metal solid form. So we write it just as its element symbol, Na. Okay. Then now chlorine gas, we must remember that chlorine is one of our diatomic elements. The diatomic elements mean that there are 2 atoms within a molecule of chlorine gas. So it will always be written as Cl2. Okay, so this is the correct chemical formula for chlorine gas because it is a diatomic. These react together to form solid sodium chloride. Sodium chloride is a compound of sodium combining with chlorine to form sodium chloride. Sodium chloride is an ionic compound. So we learned that a metal plus a nonmetal forms an ionic compound. So in order to write the correct chemical formula, you'll want to consider the ions that are combining together. You have sodium ion, which is Na plus, combining with the chloride ion, which is Cl minus. So when we combine these together, we want to be sure the charges are balanced. In this case, +1, -1, they are balanced. So we write the chemical formula simply as NaCl. Okay, so now that we have our correct chemical formulas, the next thing I want us to do is add in the physical states that are included. This is going to be solid, this is going to be gas, and this is also going to be solid. And then your final step is to identify if the equation is balanced. This equation is fairly simple to look at by inspection. We see 1 sodium, balanced. 2 chlorines, 1 chlorine, not balanced. So in order to balance the chlorines, we place a 2 in front of the NaCl, but now that unbalances the sodium. So now 2 sodiums on the right, 1 on the left. So we place a 2 in front of the sodium here, and now we have 2 sodiums on the left, 2 on the right, 2 chlorines on the left, 2 chlorines on the right. The 2 gets distributed. And now you have a balanced chemical equation. So let's consider the next example. Okay. Looking at the next example, it says here that statues made from solid calcium carbonate react with the dilute amounts of sulfuric acid in acid rain. Sulfuric acid in acid rain would mean that it's in water to give aqueous calcium sulfate plus liquid water and gaseous carbon dioxide. Okay, so now that we've read the description, let's reread it to identify what our reactants are and what our products are. So we see it says solid calcium carbonate react. So this will react with dilute amounts of sulfuric acid. So what we're going to take from that is to say that if the sulfuric acid is diluted, it means that it's mixed with water. Okay, so sulfuric acid is going to be identified as an aqueous substance, just as we've discussed in the previous chapter when we learned about the naming of acids. So now what we recognize is our reactants are the calcium carbonate with the sulfuric acid to give. So when it says to give, that also means to produce aqueous calcium sulfate, so that's one product, plus liquid water, that's 2 products, and gaseous carbon dioxide. So that's 3 products that are in this chemical reaction. So let's take this information and create it into a chemical equation. Okay, so what we have here is our reactants are going to be solid calcium carbonate and sulfuric acid. Okay, so that's solid calcium carbonate plus sulfuric acid. That's our reactants. Okay, so I'm going to run out of space to write out all the words of the products right now. So let's first just focus on writing the reactants and the two reactants chemical formulas first. Okay, calcium carbonate. Calcium carbonate is an ionic compound. Carbonate is one of the polyatomic ions that you are required to have memorized. So be sure that you're reviewing all of the naming that we have covered in chapter 3. Okay, so calcium carbonate, calcium ion combines with the carbonate ion. The calcium ion is Ca2 plus. The carbonate ion is CO3 with a -2 charge. The charges here are balanced, so therefore we write this as CaCO3. That's our chemical formula for calcium carbonate, plus now sulfuric acid. Sulfuric acid is going to be our, what's it called? Hold on. Oxyacids. So remember we learned about the oxyacids, and the oxyacids will always have the ending IC, and then the suffix part of it will help you to identify what polyatomic ion is used to form that acid. Okay, so IC, whenever we see the IC ending, this is when we're using a polyatomic ion with the ATE ending. So if we have sulfuric acid, this is coming from the sulfate ion combining with hydrogen, okay, to form the sulfuric acid. Okay, so the hydrogen ion is always going to be written first because we put the cation ion first. Then the sulfate ion will be written second. Sulfate is SO4 with a -2 charge. Now, we recognize these are not balanced. So the chemical formula will be H2SO4 for sulfuric acid. Okay, and then that's going to be, oh, I'll put the physical states in later. Okay, so now we have our reactants, and then reviewing back to the question or the statement, it says that it forms aqueous calcium sulfate plus liquid water and gaseous carbon dioxide. Okay, so the first thing here says aqueous calcium sulfate. So now these are going to be the products. I'm going to write them down here and then we'll add them to our chemical equation. Aqueous calcium sulfate plus liquid water plus gaseous carbon dioxide. Carbon dioxide. All right, that got a little sloppy, but that's okay. Now let's go through how to write the chemical formula for calcium sulfate. Calcium sulfate is a ionic compound containing the polyatomic ion sulfate. So we already went through that sulfate is SO4 with a -2 charge, or 2-, either or. Calcium, we indicated up here, is Ca with a +2 charge. We recognize that the charges are balanced, which is good. So we write the chemical formula as is, CaSO4. CaSO4, okay, plus liquid water. We know the chemical formula for water is H2O. H2O plus gaseous carbon dioxide. Carbon dioxide has 1 carbon, 2 oxygens. CO2. Okay, next step is to add in your physical states. Solid, aqueous, It said in the description that the calcium sulfate is aqueous. It said that the water is liquid. And it said that the carbon dioxide was gaseous. So we put the G. Okay. Then the final step that we have is to check to see if your equation is balanced. So let's go through each of the elements. We're going to do this just by inspection. If you need the table, feel free to use a table. Let's look starting with calcium. 1 calcium on the left, 1 calcium on the right. Balanced. 1 carbon on the left, 1 carbon on the right. Balanced. We have, now let's look at oxygen. I'm just going to go in the row here. We have 3 oxygens here, but we also have 4 oxygens here on the left. So that's a total of 7 oxygens on the left. So how about the right? We have 4 plus 1 plus 2 to give us 7 oxygens on the right. So now the oxygens are also balanced. Now let's check the hydrogen and sulfur, which is left. 2 hydrogens on the left, 2 hydrogens on the right, balanced. Now 1 sulfur on the left, 1 sulfur on the right, balanced. Okay, so in this chemical equation, there's no coefficients needed because all of the atoms are balanced just as it is written. So when there is no coefficient present, we assume it to be just 1, okay? So it does not need to be written. So we just have the chemical equation as is. And now it's balanced. Well, it is balanced. Okay, and now the third example that we have. Let's take a look. In the third example, it says here, metals can dissolve in acids. A piece of solid magnesium was submerged in a dilute solution of hydrochloric acid. The products of the reaction were magnesium chloride in water and hydrogen gas. This is actually one of the chemical equations or one of the chemical reactions that you will be doing in the ideal gas law experiment later in the semester. So we have that to look forward to. So let's reread the description and identify what our reactants are and what our products are. The reactants here, so this first statement is just informational. Metals can dissolve in acids. That's not giving you any information about what's reacting. We know that it's going to be a metal, but we don't know which metal. So let's read on. A piece of solid magnesium, okay, solid magnesium was submerged in a dilute solution of hydrochloric acid. So magnesium is going to be reacting with hydrochloric acid. The products of the reaction were magnesium chloride in water and hydrogen gas. So what we have are 2 reactants and 2 products. So let's write this out on our board. All right, so we are going to be reacting solid magnesium plus hydrochloric acid to form magnesium chloride in water plus hydrogen gas. Don't mind my scribbles there. So we have solid magnesium. So when it just says solid magnesium, it's not in a compound, it's just in its elemental form, which is in its metal form. So magnesium by itself would just be Mg. It's going to be reacting with hydrochloric acid. Okay, so now hydrochloric acid is the name of one of our binary acids that we learned. It's made up of hydrogen, and then when you see it's hydrochloric, the chloric here tells you that it's bonded with hydrogen. So we have the hydrogen ions with the chloride ions. When these ions combine together, it forms hydrochloric acid, HCl. Charges are balanced. And we're going to indicate the physical state of hydrochloric acid as in water. So that's going to be aqueous. I'm going to fill in the physical states first here. So this was solid. This is aqueous. Then we move on to our product, because now this is our reactants. So now our products are magnesium chloride, and the description indicates that it's in water. So if magnesium chloride is in water, then that means it will be aqueous. Okay? So magnesium chloride we will recognize as being an ionic compound. So we need to combine together the ions to create the correct chemical formula. So the charge of a magnesium ion is +2. The charge of the chloride ion is -1. Now, we see these charges are not balanced. In order to balance the charges, we're going to need another chloride ion to balance. So -1 plus -1 will give us a -2, and that will balance with the +2. So then our chemical formula would be MgCl2 aqueous plus hydrogen gas. When we get to hydrogen gas, we need to remember that hydrogen is one of our diatomic elements. So remember, you learned 7 diatomic elements. Anytime you come across those 7 elements, they will always be written with the chemical formula with 2 atoms. So hydrogen gas will be H2 gas. Okay? So now here is your unbalanced chemical equation with the correct chemical formulas. Then we go on to identifying if the equation is balanced. Okay? That was in the light there. Okay. So first we have 1 magnesium on the left, 1 magnesium on the right, balanced. 1 hydrogen on the left, 2 hydrogens on the right, unbalanced. So what do we have to do? Put a 2 in front of the HCl. Now when we put a 2 in front of the HCl, that also gives us 2 chlorides or chlorines. So 2 chlorines on the left, 2 chlorines on the right, balanced. So overall, all of the elements are now balanced just by putting a 2 in front of the HCl. And that completes the third example.